Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syamil Hadi bin Nasaruddin. I'm from J4EM110-4E and my metric number is 2019400618. So for today, I will make a video about thermofluid lab, which is T4 experiment. So the title will be 2 shaft gas turbine simulator. So without wasting our time, let's check this video. Bismillahirrahmanirrahim. So now we will go to the objective, apparatus and the procedure for the experiment 2 shaft gas turbine simulator. So first, for the objective of the experiment, to explore basic understanding on the functioning of gas turbine. So next is safety procedure. First, switch off all equipment after experiment. Second is caution when working with the electrical component. And the last is the wear safety boot and lab coat. So next is the apparatus and the procedure. So this is the apparatus of the experiment, which is the 2 shaft gas turbine. So for the first one is the control panel, and the number 2, which is this one, is the schematic diagram. 3 is the on-off diagram, on-off switch. 4 is the control knob. 5 is starting up value setting. 6 is the simulator value setting. 7 is the simulation monitor. And 8 is the keyboard. And next we will go to the schematic diagram of the 2 shaft gas turbine power simulator. So for the first is full inlet line, which this one. Second is the full inlet control valve. Third is the compressor. 4 is the combustion chamber. Number 5 is high pressure turbine. The 6 is the exhaust gas outlet port. 7 is the low pressure turbine. 8 is the generator. 9 is the second shaft power shaft. 10 is the first shaft, which is the drive shaft. The 11 is the inlet air port. 12 is the inlet air flow meter. And 13 is the starter motor. So now we will go to the procedure. So for the procedure, I will explain using the graph schematic diagram. So the flow is, first we will on the starter, which is the number 13. So after we on the starter, we will see the T1 and the P1. And next is, after we open the starter, the flow will go to the compressor. So when we open the starter, the fuel inlet and the inlet air port will go to the compressor, and then it will move to the combustion. So at combustion, we will check the P2 and the T2, this one. And then at the ignition, before we do the ignition, we will hold the temperature until the temperature come to 400 degrees Celsius. And then after it reach the 400 Celsius, we will release the ignition button. And then after the temperature of the T3 is 400 degrees Celsius, we will off the starter. After we off the starter, we will take the value for the T4 and the P4, which is at the high temperature turbine. And then we will take the temperature at the T5 and the P5, where on the generator power, where the exhaust inlet out. So that is for the flow. And then that is for the flow of the procedure. Then I will explain for the starting procedure. So before we start doing all the process that I said before, first we will connect the simulation model electrical to the PC, which is this one, and then we will switch on the equipment, the button number 3, and then we will switch on the PC and start the program. We will on the number 7, and then set the starting value. This is the starting value for the simulator knob. So first is the control knob number 1, we will set the value to the 1 bar, and the number 2 we will set the value to 20 Celsius, and the 3 is the knob 3 we will set to 2.33 bar, and the 4 we will set the fuel mass flow to the 50%, and next is number 5. For the load on the power turbine, we will set to 22.4%, and next is the maximum compression ratio, so we will set to 3.9 ratio, and next is the button number 7. For the maximum permissible turbine inlet temperature, we will set to 1000 degrees Celsius, and for the 8 is high temperature turbine efficiency, we will set to 60% percentage, and for the last is the low pressure turbine LPT efficiency, we will set to 16%. So that's it for the objective, apparatus and procedure. So now I will start with the table for the T4 experiment, which is the 2 shaft in the 2 shaft gas turbine simulator. So there will be 4 table for this experiment. So first is for the pressure ratio of the experiment. Next is the percentage load. The third one is the high pressure turbine percentage, and high pressure turbine efficiency, and the last one is the low pressure turbine efficiency. So for the first table, which is N_HD, is the RPM for the first shaft, and the second is the cycle efficiency, or we call thermal efficiency, and next is the second shaft RPM. It's same like this, but this is the for the second shaft, and next is the power for the second shaft, and the last one for M&D is the torque of the experiment. So I will start fill the table. Now I will go to the result. So for the discussion, we will need 4 graphs in the experiment. So first is the thermal efficiency versus pressure ratio, and next is the power generated versus percentage of load, and the third is the thermal efficiency versus HP efficiency, and the fourth is the thermal efficiency versus low pressure efficiency. So first, before we go to the plot graph for the thermal efficiency versus pressure ratio, we will need to do some calculation. So in the graph for the thermal efficiency versus pressure ratio, we will need to put the theoretical value also. This is the theoretical value that we get from the calculation. So the formula that we will use is thermal efficiency equal to 1 minus 1 over pressure ratio the power of K minus 1 over K. So the K we will get by using the equation CP over CR, and then we will get the value is 1.4. So the 1.4 we will put in the value K in the equation for the thermal efficiency for the theoretical value. So now we will do the graph. So for the first graph is the thermal efficiency versus pressure ratio. So we will get the pressure ratio experimental value for the thermal efficiency and the theory one. So we will get the graph like this. So as usual, we will quit layout. So the axis Y is the pressure ratio, and the Y axis will be the thermal efficiency. So this will be the first graph for this experiment. And next we will go to the second discussion, which is the power generated versus the percentage of load. So we will the percentage of load versus the power, and we will insert the recommended chart, and we will get this one. So we change chart design, create layout. So this will be the P and D versus L. So for the axis title will be the power load, power generated, and the X axis will be the load percentage. Alright, so this will be the second graph. And next, for the third, the high pressure turbine versus the thermal efficiency. Quick layout. So the axis will be the thermal efficiency, and the x-axis will be the HP efficiency. Thermal efficiency versus high pressure turbine. So for the last of the graph is low pressure efficiency versus thermal efficiency. So like before, we'll do the recommended chart. Layout. So because of the negative, we will get the graph like this: thermal efficiency versus low pressure turbine. So the y-axis will be thermal efficiency, and the x-axis will be low turbine efficiency. Alright, so that's it for the discussion. So lastly is the conclusion of this experiment. So first conclusion is we successfully achieved all the result and the outcome. So as we can see in the video, we successfully get all the value for the experiment and the theoretical value. And next is we successfully achieved the objective of this experiment, where to explore basic understanding on the functioning of gas turbine. So next is the experimental result and the theoretical one. So as we can see in the graph that we get before, the graph is different for the theoretical and the experimental. We can see the theoretical is the value is low than the experimental one. So next is the possible error in the experiment. So the possible error, I think the error is we will get on the simulation, because sometime in the simulation we will not get the exact value and the exact source. And next is, and I think that is for the conclusion. So assalamualaikum warahmatullahi wabarakatuh, and thank you.